All right. Um, so let's start with inverse operations. Inverse operations. Um, so basically, these are math operations. Bless you. Math operations that undo each other. Um, I'm pretty sure we all know which ones they are. Addition, subtraction. So I'm just going to put one of these two-way arrows. And then we also have multiplication and division. Um, can we stop that back there? Thank you. And again, if you ever are foolish enough to become a math major, um, you learn that this is kind of universal. Um, there's all types of different math that, or different fields of logic that use the same ideas of math that basically have these four basic operations. In some way, some things that behave like adding, operations that behave like subtraction, and they undo each other. Things that make operate like multiplication, sort of, and then the inverse of that. So really, we just have addition and subtraction. I'm sorry, addition and multiplication, and the opposite of it, addition and multiplication. Um, but yeah, it's a universal thing in math that to have math, to have a field of math, you have to add and its opposite. You have to multiply and its opposite. Yeah. Math operations. Operations. Okay, let's talk about an equation. Okay, so equations. Basically, all it is a math sentence with an equal sign. Okay, so it's just comparing two things that are equal. So as examples, we could have the very basic. 4 plus 3 equals 7. Then we could have something as complex as 2 minus 4 parentheses x plus 6 equals 1/8 parentheses 16x minus 64 plus 12. This is very basic. This is a lot more complex, but they're equations. One side equals the other. Okay? And definitely by the time we get into next year, Algebra 1, these are types of equations we'll solve. Okay? Um, let's talk about a transformation. How many of you remember learning last year, maybe the year before that, maybe the year before that? Whatever you do to one side of the equal sign, you do to the other. Does that sound familiar? That's called a transformation. um, it's basically when you apply the same operation on both sides of an equation. Okay, and we do it to balance. It's called balancing the equation, keeping it equal. Okay, so whenever we do something on both sides of the equation, we're balancing the equation. So far we talked about inverse operations. We learned what an equation is. We do transformations on an equation. Um, let's talk about a solution to an equation. All right. A solution is a value or values. So in parentheses, I'll put S. A value or values that replace a variable and make an equation true. Replace a. Oh, I put a. Yeah, I put an A again. Just need one A. Sorry. So the whole purpose of, like, say we take this equation here, this long, messy one. We do transformations on it, same thing on both sides, distribute, combine. And then eventually we get something like x equals -1. That means if I go back and replace -1 in both sides of the equation, we would get a true statement, like maybe -12 equals -12. Yes. Replace a variable. All right. So let's get to solving. Wiggle, wiggle, wiggle. There we go. Okay, so I'll give you a moment to catch up with that. In the meantime, if you're all caught up, so we're going to solve using transformations. Pretty much from now on, I'll just say solve because it's understood that what we're going to use are transformations. So we're going to do stuff like this. We're going to do what are known as one-step equations. So just one step, add, subtract, multiply, divide, will give us the answer. And let's start with these three. Okay? Now, in this unit, I'm going to give you a lot of assignments on paper. Maybe not these basic ones, but when we get a little more complex with the equations, you're going to be given assignments on paper because I'm going to ask you to show me the transformation. So, like for example, say I want to solve this. X minus 8 equals negative 7. I want to figure out what x is. But we have to show the transformation that got us there. Maybe you could think it up in your head already. That's great. But eventually, we're going to get here into equations like this. And unless you practice the basics, getting that answer is going to be very difficult. So we want to do the opposite of whatever we're doing to the variable. Right now, we're subtracting, right? So we add 8. So these are known as constants, by the way. So the constant is just a number being added or subtracted. So just write down that this is a constant. And we're going to add 8, the constant 8 to both sides. Okay? And hopefully you remember, you perform the operation, but first you see what's left. I still have an x left, right? Bring it down. These are opposites, and opposite numbers make, what's negative 8 plus 8? 0. 0, so essentially it cancels out. And on the other side, I have negative 7 plus 8. 1. And there's my answer. Okay? Let's do number 2. Negative 4 plus n equals 3. So I want to eliminate whatever's on the same side as my variable, in this case, negative 4. How do I undo that? You do the opposite. Opposite of negative 4 is add the 4. Okay? So that's another opposite. Bring down the n. And now we have 3 and 4, which makes 7. Perfect. What do we want to get rid of in number 3? The 8. It's on the same side as the variable. How do I get rid of it? Yeah. You want to get the opposite of that. So another plus 8 there and here. And I end up with negative 6 and 8, which makes, and then bring down the k. And so k is, now these are solutions, right? 1, 7, 2. How can we tell they're solutions? Yes. It has the actual value of the variable, but how do I know I got it right? Yeah. And the other thing is, what if I go back and replace x with 1? What's 1 take away 8? What's negative 4 plus 7? What's negative 8 plus 2? Negative 6. You can always go back and replace it to tell. Yes. Okay. 1, 2, 3. Let's go for 4. I'll write 3 more here. So we have, let's do a little multiplication. 6 times m. Remember, that's how we show 6 times m equals negative 24. Then we have negative 45 equals negative 15k. Oh, sorry, 4 or 5. This is 5, not. This is 6. Let's see. This will be 8 equals negative 4m. So these are all multiplication equations. I'm multiplying the variable times some number. So in order to undo that, which operation do I have to use if it's multiplication? Division. Now we don't use the little division symbol, right? We don't. Yes. Yeah, we don't do that. We do the slash for division, like the fraction bar. And what should I divide by? 6. Whatever the coefficient is, this is known as a coefficient. So my coefficient is 6. That's the number multiplying with the variable. Divide by 6. And here's why. What is 6 divided by 6? It's 1, right? So basically, we turn it into a big 1. And what's 1 times m? M, right? So these basically cancel because it becomes 1 times the variable. And so now I get m equals negative 24 divided by 6, which is negative 4. And then if I go back, 6 times negative 4, well, that's negative 24. So that is our solution. So remember, our goal when we have a coefficient and we divide away is to get a giant positive 1. So what should I divide by here to get rid of negative 15? Yeah, negative 15 again. Again, because a negative divided by a negative is a positive. So this becomes positive 1, and it cancels. Okay, so we got to divide by 15 here and here. What's negative 45 divided by 15? 3. In this case, it's negative 3. Okay, so go ahead and try the last one. Oh, yes, sorry. I just messed up myself. Wake up, Mr. Contreras. Okay, maybe you'll do better on this last one than me. Go ahead and solve it. Show the transformation, though, like we've been doing here. So give it a try. So what's our answer? Negative 2, correct. Okay. All right, last 3. So far we did addition and subtraction. Now we're going to do division equations. Let's start with number 7. Okay. W divided by 3 was negative 6. And okay. So remember we said the fraction bar means division. These are called division equations. So we want to do what to undo the dividing? Multiplication. And we're always going to divide by, it's kind of like a coefficient, it's the denominator. In this case, we should multiply both sides by 3. And here's why. I'm going to put 3, which is really 3 over 1, right? So 3 over 1 I'm multiplying this fraction times w over 3. I can cross cancel. So what is left after that? W, yeah. 3's cancel. They become 1's, really. And I get 1 times w over 1. So I got w over 1, which is just w. And on the other side, I have to multiply by 3 as well. Right? And that becomes negative 18. What's negative 18 divided by 3?
It's negative 6.
Negative 6. And so that's a quick check, mental check to make sure it works. Okay, go ahead and try these two. Multiply by the correct thing on both sides. You want to multiply because it's division equations. Okay. So you want to multiply on both sides. Okay. By the way, I put parentheses around the negative 12 because I want to make sure I understand it's a negative 12 and not minus 12. Okay. Okay, so here I'm going to multiply by negative 2. I'm sorry, negative 8. I'm going to multiply by negative 8 because I'm dividing by negative 8. Again, we can always go back and say 16 divided by negative 8 is negative 2. That's what I expect. What should I multiply on both sides here? By 2. I'm dividing by 2, so I multiply by 2. So I get negative 24 equals, cancel these guys out, so the only thing left on the right is x. And negative 24 divided by 2 is negative 12. So it all checks out. Delta. So we have a delta practicing